Indicators are weak acids with a general formula HIND or weak bases with a general formula IND-. What's special about indicators is the acid and base conjugate pairs are different colors. Another way to think of this is that indicators are different colors with an H+ versus without an H+. Let's say an acid form of an indicator is blue and its base form is red. With both forms of the indicator present, the solution should look purple. Now if we add an acid, we're essentially adding H+ to the solution. The H+, or H3O+, reacts with the red base form of the indicator and turns it into the blue acid form of the indicator, so the solution will turn blue. If we add a base to the solution, we're essentially adding OH-, and the OH- uses up the blue base form of the indicator and turns it into the red acid form of the indicator, so the solution will turn red. Hydrangeas are a natural example of pH indicators. Their color indicates a difference in the pH of the soil, so you could add lemon juice to your soil or soap depending on the color of hydrangeas you want. The most common indicators we use are bromothymol blue, methyl orange, and phenolphthalein. Bromothymol blue changes color between a pH of 6 and 8 and works well in a titration with a strong acid and strong base. Methyl orange changes color between a pH of 4 and 6 and is used in titrations of a strong acid and weak base. And phenolphthalein changes color between 8 and 10 and works in titrations of a weak acid and strong base. Both buffers and indicators are a weak acid and conjugate base system, so we can use the Henderson-Hasselbalch equation to look at the concentrations of the acid and base and how it affects the pH and pKa. When pH is equal to pKa, that means the second half of the equation must be equal to 0. The log of 1 is equal to 0, which means the concentrations of the acid and the base must be the same. So when the pH equals the pKa, the concentration of the acid equals the concentration of the base. When the pH is greater than the pKa, that means the second half of the equation must be positive. For the log of the concentration of the base over the concentration of the acid to be positive, the concentration of the base must be greater than the concentration of the acid. And when the pH is less than the pKa, that means the second half of the equation must be negative. For the log of the concentration of the base over the log of the concentration of the acid to be negative, the concentration of the acid must be greater than the concentration of the base. A simpler way to remember this is when the pH and pKa are equal, the amount of acid and base are equal. When the pH is lower, there's more acid. And when the pH is higher, there's more base. We can apply this same concept to indicators. When the pH and pK indicator are equal, there's an equal amount of the acid form of the indicator and the base form of the indicator, and we'll see both colors. So if the acid is blue and the base is red, we'll see purple. If the pH is less than the pK indicator, the solution is acidic, and there's more of the acid form of the indicator, and we'll see blue. If the pH is greater than the pK indicator, the solution is basic, and we'll see more of the base form of the indicator, which means we'll see red.